Okay, friends, today we will talk about Section 2, Chapter 7, Section 2, Capacitor and Capacitance. Capacitor is a device that is used to store energy and daily life, especially in electronics, it's very common used. As you see here, in our keyboards consist of capacitor. When we touch it, the charge capacitor work and give here a touch screen. It is used. There are many types of capacitor as you see here. This is an old model of capacitor, and here and capacitor. It's shown here, meter plates, the electrics, all of them. So let's start it. Capacitor and the charge store. A capacitor is a device that is used to store electrical energy. It stores charge, and we say it stores energy. The capacitor is charged or energized by connecting the plates to the terminal of a battery. As you see here, there is a battery, two plates, and there is battery. The two parallel plate capacitor is connected. The terminal, the plate that is connected, positive terminal is charged positively, and the terminal connected to negative terminal of battery is negatively charged. So every capacitor has a capacitance. We say capacitance is the ability of capacitor to store charge. In every capacitor on it, it is written how many. Every capacitor, it is written how many capacitance it has. Another definition of capacitance. Capacitance is the ratio of charge to the potential difference. When we connect a capacitor to parallel plate capacitor to a battery, the charge will accumulate here. So as you see here, capacitance is the ratio of charge accumulated on plate divided by the potential difference here. So let's see, the international system of unit of capacitance is farad, which is equal to coulomb per volt. And in practice, as you see here, charge is coulomb, potential difference is V, so capacitance will be coulomb per volt. And of course, it has many subunits, especially microfarads and picofarads is used. Most of capacitors exist between these two values. According to the expression, as you see here, Q is equal to C delta V. If the charge increases, here every capacitor has a capacitance, so C is constant here. So when the charge increases, potential difference also increase. When the charge accumulate, more charge accumulate, the more potential the capacitor will have. Capacitance depends on the size and shape of a capacitor. Let's see a plate capacitor here. As you see that there are two plates here. These are called, the A is the surface area of the plate. If we use big area, means that we can store more charge. So capacitance depends on this area. Second, D. D is the distance between two plates here. Distance between two foils or two plates. That D is inversely proportional. If we increase D, the effect of plates decrease. So when the increase, capacitance will decrease. And the other is the electric material. It is called epsilon in Greek alphabet. It is a constant for free space. For vacuum, it is 8.85 10 to 12. This is the basic, the smallest one accepted. It is permittivity of free space. Here, between the plates, if we put just plates, there is nothing. So it will be air between them, and it will be the smallest. When we charge more, like one plate is charged positively and the other charge is negatively, so charge can jump one to another. In order to resist it, we put some dielectric between them. So that epsilon and permittivity of every substance are different. So here we can put paper, we can put rubber or glass, waxed paper, all possible. As you see here, in many parallel plate capacitor, the space is filled with a material that is called dielectric. You know, dielectric materials are insulating materials that do not give permission electron to pass. Okay, here the electric is inserted between the plates of capacitor. The capacitance and the energy stored in capacitor increases. Since the charge increase, capacitance increase, and the energy also stored in capacitor will increase. Discharging of a capacitor. When we discharge it, when we connect two terminals of the capacitor, it will discharge and it will release its charge. It will lose its charge. Let's discuss it later. When the plates are connected with a conductor, the capacitor will discharge. Two plates, if you connect those with a conductor, electron, that's one terminal is charged positively and the other plates charged positively. So when we connect them over conductor, the electron will flow through the plus particle. Suppose an isolated conducting sphere has a radius r and a charge r, q. Its capacitance is equal to q over delta v. Since we learned delta v as kq over r, so for the capacitor, for the sphere, the capacitance will be r over kc. Here kc is Coulomb constant, so it is constant. Means that the capacitance of a sphere depends only its radius. The capacitance of a sphere depends on its radius. When radius increases, its capacity will increase. When the radius of sphere decreases, the capacitance of sphere will decrease. Earth is a large sphere. It has an extremely large capacitance. It has an extremely large radius. So Earth accepted as the source of negative charge. It can store many charge. The Earth can provide or accept a large amount of charge. And energy of a capacitor. A charged capacitor stored electrical potential energy because it requires work to move charge through a circuit to the opposite place of capacitor. We store capacitor. What is the difference between a battery and capacitor? Capacitor will always supply a constant potential difference to us. In batteries, when it runs off, it slows down. Its potential decreases regularly. But in capacitor, we can use a constant potential, how many duration we want. We can control potential with capacitor well. So it is preferred instead of battery. It's easy to charge and it is to use on a simple circuit. We can control the potential and current with capacitor easily. So in electronics, it is capacitors mostly used. And as we say here, capacitors store energy. When they store charge, they store energy. And the energy of capacitor is equal to 1 over to Q delta V. Q and delta V, We can get alternative forms of the equation by substituting the definition of capacitance. Instead of Q, we can put here CV. Instead of V, we can put Q over C, all possible. When we change them, we will get to another alternative equation for the energy. 1 over 2 C delta V square or Q square over C also is used to calculate electric potential energy of a capacitor. That's all. Let's solve some example. Here it says a 4 microfarad capacitor is connected to 12 volt battery. What is the charge on each plate of capacitor? And B, if the same capacitor is connected to a 1.5 volt battery, how much electric potential energy is stored? Let's see, given. Capacitance is given 4 microfarad. We have to always convert them to international system of unit, SI system. So micro is 10 to negative 6. We convert it 10 to 6. Delta V 12 volt and Q wanted in A. And B, it says what is potential energy if 1.5 volt is connected. Pay attention. The beginning it is 12. Later it says 1.5 volt. So A is easy. Q is equal to C multiply V. And Q is equal to 4 10 to 6 multiply 12. Q is equal to 4.8 10 to negative 5 clone. It is easy. In B, it says what is potential energy if 1.5 volt. So firstly, we have to calculate the charge that is stored under 1.5 volt. Q is equal to CV and Q is equal to 4.10 to 6. Capacitance multiply 1.5. The result is 610 to 6 coulomb. And then potential energy is equal to 1 over 2 QV square. That is the charge we store under 1.54. You have to take this, not this one. So it is equal to 1 over 2 in bracket 610 to 6 multiply square of 1.5. And at the end you will get potential energy is 6.75 10 to the power of negative 6 joule. Another question that's from section review. It says assume Earth and a cloud layer 800 meters above the Earth can be treated as plates of a parallel plate capacitor. You know, Earth is negatively charged and some clouds when they come on Earth they charge positively, and then the Earth and clouds behave as capacitor. Sometimes they produce lightning between them. If the air is not dry, if there is a rainy day, this charge can flow from Earth to clouds or clouds to Earth. So here it described that clouds and Earth are capacitor, behave as capacitor. So if the clouds layer has an area of 110 to 6 meters square, what is the capacitance? B, if the electric field strength is 210 to 6 Newton per coulomb, what charge can the clouds hold? Given. D is given 800 meter, area is given meter square 110 to 6, capacitance wanted. And in B, it says if electric field is equal to 210 to 6, what is charge accumulated on clouds, collected? Since the electric material between clouds and the Earth is air, choose here permittivity of free space. Epsilon is 8.85 10 to 12 Newton per coulomb. So first one is capacitance wanted in section A. It is equal to epsilon A over D. And it is equal to, when you put the equation with the values their places, it will be 1.10 10 to the 8 farad. And B, the charge wanted, we can calculate charge by Q delta V, but delta V here we don't know. But instead of it, we know electric field. We can use it. Instead of delta V, we can write E multiply D. Since here electron is transmitted or accumulated, here this part negative and negative will be positive, so we choose positive ED. Q is equal to capacitance 1.5 10 to negative 8, electric field 2 10 to 6, and distance between Earth and clouds 800. When you multiply them, you will see that 17.6 coulomb charge accumulated on clouds, and it's a big amount. Thanks.